Okay, everyone, this is part 2 of utilizing the bash shell to effectively manage and facilitate our duties as system administrators. Let's take a look at the first slide this week. This is a little bit of a review. We can see here just any old shell command that we want to create. Here we created a shell file called hello. It has the .sh extension right here. Now when we just try to run it on its own, permission denied, and that is because by default the user will receive read and write privileges only, but not execute. The reason why Unix generally by default doesn't allow a file to be executable is because there's a lot of dangerous type files out there, and you could have a file that the action of which could erase or delete an entire directory. And unfortunately, a lot of there's a lot of Unix in server rooms and in data centers, both served directly and through NAS NAS server farms and whatnot. And so a lot of Unix boxes are connected or clustered to entire data stores or data centers full of information, complete petabyte of, I'm going to say, very, very, very sensitive and necessary data that basically runs entire corporations. So for that reason, you have to be very careful at what a potential executable can do if indeed executed. So you wouldn't want reams of data to be accidentally deleted if the wrong executable or if the wrong script was enacted. So for this reason, by default, the any script that you write will not be executable. You actually have to turn it into an executable script, and you do that with this command, chmod or change mode u+x, so that gives the user the additional permission of being executed, and then you name the file. So thus, if you take ls and you do the long version of ls, which is the -l, you can see that indeed this file is executable. We have dash, and that one tells us what type of file it is, whether it's a file or directory. So it basically tells us what line item this is, what type of entity that this is or object, and we can see this is just a regular file because there's a dash. If it was a D, it in fact would say directory. Next we have RWX, so that says that the user can read, write, and execute, and the next permission is the group that this user belongs to, and any member of that group can only read, it can't write, and it certainly can't execute. And this is for others. This is for anyone else. They can only read it, and they cannot write to it, and they cannot execute it. Now let's take a look at the idea of variables. With variables, we can actually create little containers, and you can imagine what could happen, the possibility. Maybe what you can do is you can create maybe a script that asks the user to enter in a file name, and the user enters a file name, and then it proceeds to search for that file name. And you can imagine it within the context of this. So here we have name equals YouTube, and we have echo hello, and then name. Of course, the $ name is here that refers to this right here, and notice that there is no type. Now the reason why that is important is because we've all programmed Java, and we programmed other languages that require, there are some languages that are just very heavily typed, like Java is. I mean, with Java, you have to name the type of the variable, and then you have to name the type of function, what the return of it will be, and even if there's no return on the function, they call that a void function. So that is not what we have here, and the shell scripts, as we know, is not object-oriented programmed, so it's not OOP, so there is no need to name a type right here, and there are no spaces. So if you wanted to do things up to PEP 8 standard for Python, which is making it as reader friendly as possible and making sure there are spaces in between, the variable name and the actual contents of the variable, that doesn't fly here. There's got to be no spaces. And as it says, use a dollar sign to reference the variable name. And it's always helpful to use double quotes and single quotes. As I said, that would literally print the literal version of it. So if you said echo and then single quotes hello name dollar sign name, it would literally type out hello dollar sign name. In order for it to interpret the fact that this is a variable because of the dollar sign, you actually have to use double quotes. But do you understand what I'm saying? What the potential ramifications of this is? So for example, you can have let me just see. You can have a variable. You can utilize this command right here. Where is it? We have this command: find space / space dash name space, and then we have double quote, and I have even or odd .py. We have even or odd is right here within the Python 3 folder, because if I did an ls right here, Python 3 is an actual folder right here, and within the folder we have all these files right here that I was just messing around with one of these nights or one of these days. So in order to, and then here from the home directory, I could use, if I didn't know where even or odd is, we can say find space front / space dash name space double quotes even or odd .py. Now this to greater than sign dev null, that is to quiet down or to nullify any error messages due to lack of permissions, because if you don't do this, it goes through the entire gamut and there'll be a bunch of errors that say you don't have the permission to do this. So if you want to eliminate that, you can just do this. So you can just type in that, and as you can see, what pops out is one and only line item referring to the location of even or odd .py. Now you can imagine creating a shell file in which it may ask the user, what is the name of the file that you want to find, and then it uses the find command, and it hopefully spits out the result. So you can see how you can easily write shell commands that are actually good utilities for users. And you can also imagine just simply asking the user to type in what type of list that he wants. So you can have a script that says, what's the name of the file you want to list, and then ask it, do you want it the long version? Do you want it to show the long version and to show hidden files? And because ls-a is to show hidden files, ls-l is a long version, or do you want to combine it, ls-la if you wanted? So it's you can imagine all the useful utility scripts you can create. Here's another example. We start off creating the shell extension file, vim040225.sh, and it's a simple echo enter your name, and whatever the user types out, it reads it as the variable name, and then it says echo hello name. So here's an example of the execution of this shell file after we do the change mode u+x, which gives the user execution properties. Enter your name, Hal, hello Hal. In many examples, I use Hal because that was the name of the sentient robot that was created in the 2001 A Space Odyssey movie by Stanley Kubrick. And I do recommend everyone watch that. But you can see the capabilities here. So instead of enter your name, you can actually have a script that maybe asks a manager or something to input the name of a new user, and then the user's name is read, and all these things can be done. For example, you can create a home directory or several home directories. You can create anything automated that needs to be done to onboard this new employee. So this one skeletal example can be enhanced to do something productive. Okay, let's move on to the next slide right here. We have the person entering the name, Hal, and that matches up with echo enter your name. Now, when the user sees enter your name, he puts in Hal, and that matches up to read name. And then it says echo hello name, so that matches up to hello Hal. Now, we have here the open and closed tuple, or curly braces, I should say. And I had Python on my brain for some reason, so that is the symbol for tuple. So this is the curly brace right here. So when you combine $name with the open and closed curly braces, and apparently adding in a pound sign, you can get the length of the character that the user entered, the length of the variable name that the user entered. So we have hello Hal, character length is 3. In another example where it says enter your name, he puts in Nitro, hello Nitro, character length of course is going to be 1, 2, 3, 4, 5. Character length is 5. Here is an example of if-then logic. So if we go all the way here, we can say it's like if some condition occurs, then this happens. However, if the condition matches this, then this will happen. If none of these conditions match the logic, then the default happens here. It's like the switch logic, in which you have case 1, case 2, all the way to the end cases. If none of those cases match the input, then you have the default, which is the catch-all, and that's what this is. So if we go back to this situation here, and that is this, we have if decision equals 1, then and it says enter name. Now if the decision does not equal 1, then it'll just say anonymous. So in this first line, it combines this echo and then read into one line. So we have read and then the quote enter name, 1 for yes, 0 for no, and we have the containerization of this decision, which is DEC, and it says if DEC equals 1 or equals, remember 2 equals is comparison. So if the deck or D's decision variable matches 1 or is comparison to 1 successfully, then it'll go through the algorithm, enter name, and then it'll say hi or yo name. Now else we have name is anonymous. So this is an example of a default variable in which the tuple now, instead of it being the length of the variable, it now has a default value of anonymous. So here it says enter name, 1 for yes, 1 for no. The decision is 1. Thus, it asks you to enter the name, and then it'll say hello, and it'll issue out a greeting. However, in the case of 1 for yes, 0 for no, and he puts in anything other than 1, in this case just the letter B, it'll say hello anonymous, because that is the default value. All right, here we have what's known as a subshell, and the symbol for subshell is the parentheses sign. Just that we have the starting and ending parentheses, so anything in between there is our subshell. Here, for example, we have present working directory, so if we type into pwd, this in fact is the output for present working directory. However, if you type in the open parentheses and then you type in change directory to the intern resources, and this would be statement 1, and then you do statement 2 within the parentheses, and it's separated by the semicolon. That's our delimiting character right here. So the computer knows when the next statement is ready, and you may want to put a space right here just for formatting purposes. So this is statement 1. This is statement 2, present working directory, and we can see that after in terms of the subshell, after you change directory to here and you type in present working directory, this is the present working directory of the subshell. Now, if you type in present working directory, this is the present working directory. You can see that matches this because we are no longer dealing with the subshell. So as you can tell, the subshell commands do not impact your current shell, and that's the point. The point of the fact is that you can have a shell within a shell. All right, this next section, we're going to talk about AWK or awk. Now, awk is more than just a way to format things, as you can see here. It's an entire different computer language, much like Python. There's Python, C, C++, Ruby, and other languages like that. You know, before Python and before Ruby, there was awk. Now, awk is an acronym standing for the three gentlemen that created this language that was written at the dawn of Unix. But right now, there's different variations of awk. There's mock and POC and all that. Right now, we're just dealing with vanilla awk or just awk. So right here, we can say PS, which lists all the processes right here. We can do the same thing with awk, except we can decide which column we want to print. So we have print $1. That refers to the first column. So this would be column 1, 2, 3, and 4. So if you say $1, it's only going to print out this first column. Now we can also say print $2. That's going to print this column right here. And if we just say $0, unlike other languages that if we have an array and we have 1, 2, 3 things in the array, it's only going to be a 2 count because everything in most languages start at 0. And then it goes 1 and then 2. Interestingly enough, I believe MATLAB starts with 1. There is no 0 in MATLAB. But that being said, if we said print 0, there is no 0, so it's going to print out the entire thing anyways, as if we just typed PS. Now the output of cat etc password. This is like the last 4 things right there, and I think JSON would be 1000. So usually when you see me type out the SC password, you're going to see JSON right here above test because that's the UID of 1000, but I just didn't include it in the output right here. But if we did cat etc password with awk, we can see that we can tell it to only print the very first column by saying awk-f, and this makes the colon the delimiter right here of columns, because as you recall, we can see everything, all the columns are separated by colons right here. So that's the rationale of this F space and then colon in quotes. And here we have print $1. That tells us to only print the first column of the etc password right here. Now we can say print 1 and then concatenate that with a space and then move on to $3. So we are skipping the first 2 columns. Now, if you were looking at this, it's going to say user client 1. It's going to skip this password because that refers to the shadow file, so that's moot. And then it's going to go and move on to the UID or user ID. So we can see that if, let's say, your boss, and you can also specify a tab, so that's the /T. But if your boss said, hey, I just want a list of all of our users and their corresponding IDs, and you could port that to report something, we'll say file f.txt. Maybe you could port that to a file text, and it would only, and it's just something that's easier to the eyes for your boss if he wanted to see just all the users' names and the IDs in this case here. And you can like I said, you can make specific reports. So here we are using awk to only provide the JSON username, so it's going to show things that are filtered only for JSON. Now here's something interesting. Here you're asking awk to prepare almost like a report for those user IDs that are above 999. And for those of you that don't know, the significance is the fact that those are regular users. Anything 1,000 or above is regular users. So this is great if your boss only wanted a report of regular users. So he wouldn't get like SSHD or Telnet D or something. Just regular users. And again, here is the same request, except you're porting it out to a report. So that is something that you could generate a report, maybe turn it into a PDF and email it to your boss or something like that. All right, now we're going to not necessarily move on, just change the subject. See, the things I've gone through with you with the shell scripts and using awk, I mean, it wasn't even close to being comprehensive. What I'm doing with you is just wetting your beak per se, so that in the future, if somebody talks to you about shell scripting or talks about, something about awk, and you're not going to see a lot of awk in today's networking environment, but you can introduce it. You could just tell yourself, you know what, maybe this would be easier with awk, and develop your own things, doing your own research. And the more things you are exposed to in school, the more you can bring something perhaps different to the table when it comes to your job. Similar to this next topic, we're moving on from shell scripts, which is very, very much on point using your server. But if you want something a little bit more portable that can go between servers, and you can utilize Python or another OOP language. And the reason why Python is so applicable to servers is because it has exterior or external packages like the OS. Like, for example, import os.name posix, which is basically slang for Unix or any C-based, as in the letter C, as in the language, C scripting, the C-based languages such as Unix and Linux. Basically anything that ends with Nix. Here we have import os.get UID. Then of course that goes to the username that you are logged in as, and you can see that it is 1000, and the 1000 right here is going to be tied, or is going to be linked to the user ID of the logged in user, or the user that's actually programming Python 3. We can see they are both 1000. And here we have import os.uname. Of course, uname is a familiar command in Linux and Unix. And this, of course, gives a very, very thorough output of uname. Actually, this is this kind of resembles more of a uname-a. That's how complete it is. I mean, it literally gives you everything. It gives you more complete information than the uname command in Linux, believe it or not. And then here we have Python 3 os.path is file loopy.py, and you can see that it does exist. So this asks a question: does the file exist? That's what that's what the is file method does. And of course, the parameter is the name of the file you're checking out, and we can see that it is true. And here it wants the absolute path of loopy.py. We can see that is the absolute path. And then finally, we can use the os.system module, or we can say the os.system command, and system is a method of OS, and then the parameter is the actual command. So here we can actually run OS specific commands, whether or not you're on Linux or Windows. In this case, OS system ls, and we can see that the Python 3 findme.py actually lists all the ls output right there. It lists the ls output. So the missing aspect to this slide is the fact that this is the program for findme.py. So the first thing I did was I used Vim or whatever to create findme.py, findme.py, and this is the information. This is the script within findme.py, and all it does is it imports the OS module, and then it says os.system, and then whatever command you put in here, guess what? It outputs that command as if you actually typed in ls in your command line interface. Now, this is the same whether or not you're running the terminal in Linux or you are running PowerShell in Windows.